an ACPC transformation using 3D-Slicer. So first of all, I'm using the HCP 100 unrelated patients dataset, in which individual files are compressed into this .nii.gz file format, and 3D-Slicer does not support that file format. So the first step would be to uncompress one of these MRI files, and it outputs as a .nii or a nifty file. So if I open up the 3D-Slicer GUI, I can just drag this MRI image into 3D-Slicer. And in order to make my workplace more cleaner, I can close the 3D viewer and just focus on the MRI images. So let's look at the AC and the PC before we do the transform. So you can zoom in using two fingers. You can pinch to zoom in, also pinch to zoom out, and then you can move back and forth through the MRI using your scroll wheel. And if you want to shift the image, you can hold down the shift key and just press and drag and orient the image into the window pane. So let's see, so this would be the anterior commissure, and this is the posterior commissure, and the posterior commissure is slightly higher than the anterior commissure, and you can kind of make out that the head is kind of anteriorly tilted, so the ACPC line would be crossing somewhere like this, but the patient's head is tilted and we need to fix this. So let's start by going into modules and opening up the ACPC transform module. This is what the interface for that looks like. The second step would be to go to input landmarks and select the ACPC line, and you want to select create new line. As soon as you click that, this option would open up. I'm not sure what the exact name is, but you can click on it, and let me just make sure that I can visualize the AC and the PC in the actual image. So I cannot see the AC and the PC in the same image. I see the PC here and I see the AC kind of here. So let's just mark AC first. So you can see the anterior commissure as a white matter bundle, and if you move back and forth between the slices, you can kind of see it. It's kind of animated and moves towards the midline. So if you focus on these bundles here, and then you can see them crossing, that's the AC. So let's arbitrarily mark a point right now and then refine it in the sagittal section. So I'm going to select this tool here, click once on the AC, and then move my cursor behind. Just make sure I'm in the midline. I can't see the PC right now. I'll just leave the point here. Yeah, so I'm happy with the orientation in this image. Now let's look at the sagittal section. Yeah, so this structure here is the AC, and we just want to arbitrarily mark the posterior most point of the AC, which would be somewhere here. It doesn't matter if you're not super precise, because it's difficult to decide whether to place it here or place it here or here, but as long as it's the posterior most point, and if you do the same with the PC, we're just concerned about the angle of the line and not the length of the line itself. So you should be fine. And this is the PC, and that's the point of the PC. This is the PC here. I want to move this to the the anterior most point of the posterior commissure. I'm happy with that. Let's look at it in the actual image again. So now I can see that it's not quite in the midline. So let me refine that. Yeah, I'm happy with that. And let's look at the anterior commissure as well. Yeah, and let's refine that as well. Yeah, so I'm happy with that as well. Let's go back to the sagittal image and just confirm whether, yes, move this here. So yeah, I'm happy with the ACPC line. So in order for this to work, you need to mark 3 points at the midline as well. So let's go into the interface again. Let's select create new point list for the midline. Now we'll have to use this tool to mark those points. So let's look at the cerebral aqueduct. So once you go inferiorly from the third ventricle, you can see that the third ventricle forms the cerebral aqueduct, which opens up into the fourth ventricle here. So you'll see this aqueduct as a round structure, and then you can see like two Mickey Mouse ears of the midbrain around it. So once you see this structure, which is the aqueduct, you need to like zoom in and mark the midpoint. So let's do exactly that. That's point number 1. I'm quite happy with it. You can choose the second point as probably the point between the two cerebral peduncles here in the midbrain. So this point could be another midline. You don't need to be like super precise, but be as precise as you can. And then for my third point, I'll choose just a point in the third ventricle, I guess. So let's just choose this point. If you want other points, you can probably place it sequentially in the aqueduct here, somewhere in the third ventricle here, or this point here in the aqueduct, this point between the peduncles. So just, you have a lot of points, but you didn't need just 3 of them. So once you're ready with that, select an output transform and just create a new transform, and the output would be saved under the name output transform. Click on apply. So we're ready with the transform. Let's look at the sagittal image. So you can just double click and open that image. If you double click again, you go back to this original view. Now let's go, in order to apply this transform, so right now the head is still tilted. In order to apply the transform, you need to go back to data, and you can see the MRI, the ACPC line, the midline, the 3 points of the midline, and the output transform that we've created. So you want to go and select the MRI, the subject MRI, and go into this grid right here and right click on it. Then you want to select output transform, and if you look at the sagittal image, there, the sagittal image is now oriented according to the ACPC. And in order to fix this and make sure that this image stays here, you're going to right click again and click on harden transform, and that's it. And if you see these points here, these points have moved, but that's, you can ignore that because the AC and the PC are at the same level. These lines have moved a bit after you've clicked on harden transform, but that's fine. So now you can make all your measurements in accordance with the ACPC line, and that's it.